All right, in this section, left a little bit of notes. Vertex, if they ask you to compare maximum and minimums, they're asking about comparing the y value for the max and the minimum. As far as the vertex, the y value of the vertex. And then concavity, concave up just means it's facing up. Concave down means that the quadratic's facing down. Don't forget that means it's a positive in the front if it's facing up, negative in front if it's facing down. Here, just did a couple quick examples. So, which function has the greater y-intercept? So, we know the y-intercept for this one is 12. It's in standard form. That's nice and easy. And then over here, our y-intercept is 1. So, which one has greater? Notice that they're naming this g of x, this one f of x. So, that means that g of x, the y-intercept of g of x is actually less than the y-intercept of f of x. So let me put y-intercept of g of x is less than the y-intercept of f of x. Because f of x y-intercept is 12, g of x is 1. So actually to answer the question, which one's greater would be f of x. And then looking at this one might as well, just because these are so quick, how many roots do the functions have in common? So remember, roots are zeros. So I'm going to look at this one. Let's go ahead and factor that one down. That's x plus 3, x minus 2, set it equal to 0 to find the root. So x equals negative 3 and 2. So those are the roots for f of x. This is for f, and then for g of x, so just don't forget this is f of x, and this is a different function, g of x, so keep that in mind. G of x has negative 1 as a root. I don't know, I did blue on blue. Let me do it in red. Negative 1. And I'm going to go up here, and negative 1 is not one of our roots. And the other root is 2. Well, right there, if you look at that, 2 is the same as that root there. So how many roots do the functions have in common? That would just be 1. They have one root in common. Let me just put that, one root in common. So just go through those assignments. Should be pretty easy. Just kind of take your time. But from everything